Um, since it's a conference is about data, there were different ways to think about this, and I decided that probably it's interesting to look a little bit more on the technology side, not so much on the social and political implications. So I'm going to dive a little bit deeper, and primarily I'm going to talk about what it actually means to build a data-driven business. So ultimately, if you look at advertising, advertising is a data business. So if you think about what you're actually doing, it has all the things of a regular business. So you take a commodity right now, which is pixel space on devices. So if you take the average, small banner, it's 320 by 50, so you have 60,000 pixels. And that's what we're all competing for, and we're trying to price these 16,000 pixels. And so we are effectively fighting for real estate, which ultimately we are fighting for eyeballs, but we are all fighting for this little real estate. And then the value creation we are doing is how can we deliver how can we fill those 16,000 pixels with a message which actually gets paid by someone because he wants to get impact on a person who is seeing them. And so the value creation is really the refinement and the selection of what to show. And if you think about what we are doing when we are anything we are producing, right? We are taking raw materials and we are converting them into something. So you can, if you look at a car, right? We are buying steel and leather and plastic, and we put it all together, and there's a bunch of engineering involved, and ultimately I get a car. And the refined product is much more valuable than the raw material. And this is effectively what we're doing here. We are taking a raw material, which is pixel space, and we're trying to refine it and create value with the refinement. So then there is a very clear measurement, and there are effectively, for most products, there are two ways how to look at it. It's either you give really, really good quality, or you give really cheap price. This is usually how you win in the market. And in advertising, there are both ways how you can do it. Both sides exist and coexist, and there are different buyers for these different products. So it's a very clear business. So it's just a digital business, which is data-driven. Now, the difference, I think, in advertising to many other businesses in the data world is that it's really a big data business. And so it's not just showing 16,000 pixels, but actually showing that at scale, and the scale is massive. So if you think about it, in the world right now, the mobile devices we all carry, right? It's over 1 billion devices you can observe. And then there is, if you take all the exchanges where you can actually buy this inventory, we are looking at about 40 billion impressions a day. So there's 40 billion times that there's an opportunity to actually buy these 16,000 or whatever many pixels and show an ad. So there's a lot of inventory, and usually it's unfilled. So ultimately, the business in advertising is to cherry pick. There is certain inventory classes which are like completely overbooked, and then there's a price war, but usually it's underfilled. And those things get actually traded in different exchanges in the world. So imagine the whole process is there's an eBay transaction an eBay-like transaction, except it takes 100 milliseconds. And so within the 100 milliseconds, you need to give your bid, and then if you are the highest bidder, then you win. Now, on the data side, if you have 40 billion things, they are usually descriptions of what the phone is, who the user potentially is, a bunch of other stuff. They are around a kilobyte. So we are talking at 40 billion transactions. You are talking about 40 terabytes of data which come into your data centers, and that's a lot of data. So this is non-trivial. So imagine, right, you have your 3 terabyte drive, and usually you have a triple replication, so if these things fail, so it's effectively each terabyte is one drive, so you need 40 new drives in your data center every day. So now you can try to compress it and do a bunch of stuff, so maybe you get it down to 4 to 10 drives a day, but it's massive amount of data. If you take those 40 billion impressions and we break it down on a per second basis, it's 500,000 impressions per second. So you actually are trying to price 500 million things per second. So in most cases you actually drop them, but at least you need to look at them and drop them and make a conscious decision that you don't want to look at it. And then overall, your latency with the exchanges, that transaction runs for about 100 milliseconds. After the 100 milliseconds are over, then the opportunity is gone. You can report about it, but so you have 100 milliseconds. Now, the 100 milliseconds is not really 100 milliseconds. The problem is this. If you look at the world, we have all these different locations, and there is actually statistics which show that if you're responding within certain delays, then the user interaction, actually the user experience gets so bad that people actually abort it. So you're buying the ad, you price it, you want to show it, it actually takes too long to load, so people actually don't care. And so what happens is that if you look at the world population, all these different centers, and so you need to actually look, at the latencies, but also you want to be close to the customer, like the user. And so people started trading at different locations in the world. Now if you take 50 milliseconds round trip, then you effectively have 25 milliseconds. Now you take speed of light, then you in vacuum, you multiply it with 0.65, that's your speed in the fiber optic cables. Then you add another 50% because the telcos are really bad. And then you actually get to these circles where you actually need to place data centers all around the world to actually do that data business because you actually need to be close, okay? And so you can now imagine, you want to pop some more in different places, primarily wherever you can buy that data, that's where you need to be. So, for example, we have a data center in Hong Kong. From Hong Kong, we can reach Japan, we can reach Singapore. But so you are sitting there with Google Maps and you're trying to figure out where you put your business, okay? It's very interesting to actually have, like in one data center, we have Chinese people doing the cabling and then Korean people controlling the switches, and it's like you have a lot of funny people on the phone. And so now, if you look at that, it's actually on the technology side, it's also a very big challenge, which is scale and cost. And oftentimes we completely forget that. So it's like all these funky things. You want to build technology, but when the big numbers in big data get big, the price gets big. And so just to give you an idea, so let's say you're trying to build a really, really awesome predictor and you're willing to spend 3 milliseconds on it. 3 milliseconds doesn't sound like a lot, right? The problem is the volume. So if you have 500,000 impressions, then for these 3 milliseconds, then every core effectively needs to compute. A processor core can only do 300 predictions. So if you have 500,000 a second, you need 1,500 cores. Okay, so 1,500 cores, if you buy a really nice machine, 12 cores in it, blah, 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 you get it to around 150, 200 servers. It's a lot of servers, okay? It's a lot of power. So if you go to Amazon, that's $200,000 a month, okay? For the data volume ingest plus the process. So now you're in a business where your baseline cost is $2.4 million. You haven't hired a single person. So in this way, you need to start thinking about cost and looking holistically in your data business. So if you cannot get it down by 10x, you're in deep trouble. And so I'm not going to tell you how to do this, but I'm just trying to give you some ideas how to think about big data businesses. And I'm sure that everybody has their own story, so this is effectively my story here. Okay, so then we are running. The next thing you do is you are actually trying to predict, right? So you have all this data and you're trying to buy the good data. You want to get rid of the bad data because you want to have all the other guys buy the bad data. And so what you're doing is you're building all these predictive models where effectively you have the data and then you stick it into this algorithm, and then the algorithm gives you a price, or it gives you a probability. And so for example, we have predictors which say, okay, what's the probability that actually the person is going to click? What's the probability that the person is going to click and land on the web page? What's the probability that he's actually going to browse on the web page? What's the probability that he's going to buy something? And so the more data you have, the better your predictive model becomes, and then actually the cost for the advertiser goes down, and you stop spamming the whole world with your ads, but you actually send them to the people who care. And so this is, it's a win-win for both sides, and ultimately, the value creation now becomes clear because, like, okay, we're using raw material and we refine it to something where actually there is a value in that refined material. Okay, but now this is not good enough. So usually there's like advertisers have a good understanding, or in many cases they have good understanding what what their audience is, so you start saying, okay, actually I want to target demographically. But getting demographic data is not easy in particular with privacy laws. So trying to do approximations, and so you're actually building predictive models where you say, okay, if I know about some group of people, something about the demographics, why can I not extrapolate to the rest of the population? And I may be a little bit off, but if my signal is good, then I can actually say, yeah, these guys are male and these guys have the same browsing behavior, so maybe they're also male, even though that I don't know. So you need a certain ground truth, and then you can extrapolate. And the same thing goes for demographics, sociographics, interest. Fraud is very interesting. So about 50% of all the clicks are fraud. So you don't want to sell fraud to your clients. They're not happy. And then site classification. What is a site about sport? So there's a lot of natural language processing. It gets really complicated when you go into like, I mean, at least for me, I'm speaking German and English. I'm not speaking Chinese. So if you want to classify apps, it's really hard. Currently, right now on the App Store, there are about 5,000 new apps every week. So it's incredibly hard to just do basic classification and making sure that you are not advertising on smut or political stuff, etc. So, and then when you are doing your predictive algorithm, what you're doing is you're training. So you potentially sit on hundreds of terabytes of training data. So I mean, if you have 40 terabytes a day, you want to train over 7 days, it's a lot of data you need to actually touch. So you need to actually suck it off drives, which actually explodes your server cost more. So if you have a couple of hundred server in your data center, it's a lot. Then usually the next problem is when you're starting to train your algorithms, you don't want to move the data out of one data center to the other because the data transmit cost is so high that you actually need to think about how you're training distributedly and then actually stitch the data together. And then some of the algorithms you actually want to retrain very fast because after a couple of minutes you can actually improve the prediction, in particular when you're starting new campaigns. You see how users behave, and then so there is a very short turnaround in certain cases. In other cases you don't care. People don't change agenda that often, so it doesn't matter whether you train once a week or once every 3 days. Good. And then the next thing is you need to enrich data. So when you're building your predictive algorithm and you're starting to annotate your data sets, then you actually want to enrich the data which comes in from the exchange with the data you computed, so you have suddenly custom data, right? So you know that someone is a male or female and the others don't, so that's the valuable data. So this is where I can actually, everybody else is in the blind, I actually know something. So I buy it at the price where everybody buys the unannotated data, but I have it annotated, so I get a competitive advantage. And so there are different things like users, location, devices, weather data, and if you then roll this all into your predictive algorithm, you can actually get extremely good outcome, and it's measurable. Like in the boost is dramatic. So then, if you think about this now, you effectively are having this humongous database, which is distributed in 4 geographies, and then you have tens of billions of records in there. And now you are accessing this 500,000 times a second. Okay, so it's a insane system you need to build just to get very basic. I'm participating in the ad market. Okay, so you have around 1 million IOPS you need to sustain. So just to give you an idea, a regular spinning hard drive is 50 IOPS. So usually you don't use spinning disks, you use a lot of memory and SSDs. But then there's also price points. So if you have 10 billion records, each record is a kilobyte, you need 10 terabytes of RAM, it needs to be replicated, so 10 terabytes of RAM costs a lot of money. So this, just economically, you need to effectively go design your system for the price point you're trying to achieve. And I think ultimately this is just one case, and other industries will have other sweet spots, but looking at the whole stack is really important, that you can actually get to the price point you need to achieve to build a data business. And then the predictive model is really important. So we see tremendous impact if you actually have a good predictive model. Like we had a very basic model when we started out, and we actually improved our performance 5 to 10x just by having a better predictive model, which ultimately has an immediate impact on your overall cost and customer happiness ultimately. And so what we do is we price every individual impression. So which means that every impression we are actually considering, we throw it through a pricing algorithm and it comes out and says, okay, this is what it's worth for us. So and this is really, it's very powerful, but it's very computationally intense. And then what we saw is that basic filtering is completely insufficient. So you need to price. And you cannot pre-compute the price. You need to actually price every impression. If you look at very successful data companies like Netflix, Amazon, this is what they are doing. They are going down to the individual and they're trying to find the perfect set of parameters and recommendations, etc., for the user. And ultimately, it's the same here. So we are effectively every ad is kind of customized down to the user. Not necessarily the ad itself, but the price of the ad. And then there's this continuous model update. So you're actually running this, and then as you are going, you're learning, right? So you want to take certain users out, you want to add other users. And so there's the immediate update with every impression, and then there's the more long-term update where every hour or every day you are refining your model. So you're kind of, the model is drifting toward a better point, but then you go and you actually look in the entirety and then potentially re-optimize. Okay, so overall, what we noticed is, I mean, I did high frequency trading, and then I did this, or I'm doing this right now. There is a kind of blueprint which kind of emerges how you build a data-driven model or data-driven business, and I've seen it now the third time. So I built 2 high frequency trading systems, and now the advertising business. There's one thing which is really important. You need to look, you cannot just look at the technology. So it's not like here is the big Hadoop hammer and you're done. It's much more about the integration, the end-to-end integration to build a process. Think about technology and think about the business process you're trying to build. And then the nice thing about data is you have a feedback loop. And this is, I think, one of the best things in that business, that everything is measurable because everything is quantifiable. And when you're trying to optimize, then you automatically already built the feedback loop into the system. And you sit on all that data. So you need, but you're drowning in data. So it's extremely hard to actually say what data you should look at. So you need to think about what are the ultimate KPIs and how you're extracting them and how you're optimizing your business around that. And you need to build the overall architecture around that. And so it's also like the day-to-day operations, right? It's like there's not a I'm done, this is, now it's good. There is effectively a constant improvement. There's a bunch of people constantly working the system. So we have software updates like 3-4 times a day sometimes. On the other hand, we built a system so that people can go home. Like the system runs completely unmonitored overnight, and it's self-healing. So if there's something's falling down, nobody touches it, just figures it out itself. Potentially it reroutes to a different data center. If the server goes down, nobody notices. So, and this is really important so that you are operationally, if you don't remove your hands from this thing, you just cannot sustain it. You will just drown in people and labor, and things blow up, and there's always something going wrong. So you need to build this system around like kind of lights out administration. The blueprint how to build this, I think, has been refined now over 15 years, pretty much. In the late 90s, when the high-frequency trading world came out, they, I think, were the first ones who actually started building real data-driven businesses, which were sole data-driven. Like you connect to the internet or to 2 Ethernet plugs. There's a buyer and a seller. I'm sitting in between. And this was kind of the first time that that you have fully computerized data analytics-based trading. Or refinement of raw materials. So I mean, in trading world, it's primarily sitting in between. But the interesting thing is, if you look at what all the components you need, it's effectively the same thing for every data-driven business. And so that there is a blueprint. The blueprint has been refined now, and so pretty much the way we see this is now there are like 7 things you need. So you need the data acquisition model. So somehow you need to get the data, and you need to be really smart about this. The thing is with getting the data into your system, it's not just I take it, I ETL it, I store it, and then something will happen. But pretty much because you are reacting to the data, your data acquisition is much more taking it in, immediately processing it, and then storing it. I mean, you're not ETLing 40 terabytes a day. There's just no way. The amount of servers you need to put there is just staggering, so you are not touching the data twice. Then you need to find a really good storage system. It needs to be self-healing. You never touch the data. Data at rest, it stays there. And so you need to deal with update cycles. You need to deal with data failures. People, like there are bugs in your ETL pipeline or in your ingestion pipeline. You need to be able to replay the data, fix it, etc. So you need to plan for this. Then you ultimately have some form of analytics. So batch analytics here. There is you need to think about what's the model of actually, or what's the system, how you're building your models, how you're testing your models. The next one's model testing, so you need to replay data. It's also integration tests. So I mean, if you think like when we run our bidder, it runs on a couple of like tens of cores. It's below the hundreds. So you actually wanna test that the thing actually does what it's supposed to do. It's very hard because to really do a full integration test, you need another cluster, and you just don't have the capacity. So you need to find other ways of doing performance optimization. So it's a lot about thinking about simulation environments is really important. And then there's the whole time series data. So we are at some point we were looking how we can represent like a 20, 30 dimensional data cube, which grows by a couple of gigabytes every day. And this is really critical because the whole business depends on that. And so you need to think about how in that data pipeline, you're continuously creating this output data where you can effectively, your data analysts can look, your business people can look, and your engineers can look whether the data actually makes sense. And so you need to build that into that pipeline because once it's in production, you can never go back. It's not like, oh, let's restream, the last 4 weeks of data. That takes you 2 weeks, or and your cluster is busy, so you're not doing anything else. So there's a lot about how do you deal with failure. Failure management in production is one of the key things. And then dashboards and reports. So you need to find something where you can quickly throw something together. And so we are. One of the things we decided was to go with like stock enterprise BI tools, just tweak it so that it can deal with the data volumes and break down the data volumes so that someone who's not an expert can just take an Excel and point effectively at a data cube. And then, you just give this data cube a ton of RAM and a ton of SSDs so that you can actually sustain the IOPS. So, and sometimes we're trying to build something incredibly good and new, but there are a lot of solutions where if you are careful and you look, you actually get good, like if you optimize your system, you get good outcome with existing tools off the shelf. Okay, so that's the conclusion. I want to make this more like interactive and have people ask questions, so I'm open to answer anything. Everybody is full from lunch. Yes, please. Sorry, can you? No, we buy the media. Yes, we run the campaigns. Yes. Yeah. So I think that breaking up there's a general industry trend to kind of have the DMP and the DSP. Ultimately, if you break up that value chain, you cannot optimize end-to-end anymore. And I think the big value is in actually this end-to-end, knowing what the customer actually is looking for, and all the way to the execution. Because if you break that model somewhere in the middle, then you need effectively an interface, how you can transpose what you learn on one system and then actually use it in the buying, on the buying side, so your price prediction will not be efficient enough. Okay, any other questions? Yes, please.
Okay, so you've been talking about scaling the request dimension. So in a typical DSP system, you also have a number of campaigns. So this would be a second dimension that needs scaling.
Yes.
What is your approach towards that, so you don't get like square root?
Yeah, a compiler. Is that a good answer? It's an optimizing compiler, yeah. So you compile the campaigns into basic building blocks, and then you run standard optimization over it, and then you're effectively trying to break it down into parallel building blocks.
Okay, and so now taking the 500K request that you've been talking about, what factor would you say do you currently have to multiply that with to get the final number of decisions that you're calculating?
It really depends on the country. So, I mean, if you're running in the US, it's 45% of the traffic. So once you start US campaigns and they are not, I mean, so what you do is you effectively push all the filters that are cheap to as early as possible in the pipeline. And so usually you dramatically cut down on the first data intake. So, and then if you look, I mean, about I would say 55 to 60% of the inventory is garbage. You cannot bid on it, and so that cuts down to half. And then you effectively are trying to narrow it down. So you're really trying to push the funnel down. That when it hits the pricing part, you actually are to a point that it's not expensive anymore, and you can actually sustain the I/O.
Okay, thanks.
We had a lot of questions about data ownership.
Yeah.
So, and there are a lot of exchanges like Google Exchange that they say in their contracts that you're not allowed to learn from the bid requests.
Yeah.
But that's what practically you're doing, right? You're learning from any.
So what we are doing is we are actually. I mean, this is it's a very important aspect of the business. I mean, in general, I think in the data business, you need to adhere to you know what the requirements are. So there are different exchanges with different rules. There's also contract negotiations. So you are effectively looking. I mean, every piece of data we are taking in, we are tagging, and we effectively have the rule engine, which then potentially either anonymizes the data or drops it and doesn't consider it. So we are effectively tagging the data and the input source with a kind of contract identifier. And then based on that contract identifier, the learning algorithms can pick it up or not.
So you're not learning from the Google Exchange?
No.
Or?
We are not learning from the exchanges where we're not allowed to learn from. Very simple. So, and yeah, I mean, in general, there's a trend, because I think the exchanges are figuring out now that data ownership is one of their core business, because they are not providing much other value. And so they are all desperate to find a business model which is sustainable. And so they are effectively clamping down on data ownership. Yeah. And I mean, this is a trend in the industry in general. But on the other hand, there will be a point that if you clamp down too much on data ownership, then whatever you are providing doesn't have value anymore. So this is the trade-off, right? So if they say you are not allowed to learn from my data, but you should buy my product, I was like, well, I cannot buy it because I cannot price it. So I price it at nothing. And so there will be the point where if I cannot price it correctly, I undervalue it. And so ultimately I will shift my purchasing decision somewhere else. And then that will shift the publishers to exchanges where actually they are more liberal with the data. You know? So I mean, I think it's because it's a marketplace. I mean, we see this with a lot of apps, for example, like the standard high volume app actually sells its inventory across 10 exchanges. Sometimes even the same ad impression gets sold concurrently at multiple exchanges. And then they actually get the bids in, and then they take the highest bid and tell all the others, okay, we didn't show it. So there's a lot of optimization which happens on the publisher side, because ultimately they're also in the business of selling the real estate. Yeah. Okay. Any more questions? Yes. I mean, you use, ultimately you'll have a model, right? So, and there is a point where you will not improve the predictive model anymore when you stick more data in, and that's when you can start retiring. And so it's effectively just a price point. So how long, like how much do I pay to house the data and how much do I pay to process the data, and what's my lift ultimately in my predictive model, right? And so you need to find that sweet spot for your algorithms. And sometimes it's like, okay, you know, there are retirement policies, so certain exchanges say you can keep things for, let's say, 6 weeks, and then after 6 weeks, you need to retire, and you can train for your trading algorithm, but you cannot use it for cross-exchange stuff. And so you effectively just go in, and whatever that policy is, you just drop the data. It's pretty much what Google does, what Facebook does. So you just need to build this into your model. So you effectively are retiring the data whenever either it's not valuable anymore, or when you have to legally. Yeah. But yeah, it's very hard in particular when you have like English written contracts. You need to effectively convert an English written contract into an algorithm. And so that's non-trivial, and you need to make sure that the team is actually understanding what it means. So yeah, that's a non-trivial thing. Yeah. Okay. Any other questions? All right. Thank you.